So, do you guys recall, if I have something like this, how many answers is it supposed to have? Three, yeah. The degree tells you how many answers. That's like a theorem we're supposed to learn today. I kind of mentioned it last time, but yeah. The biggest power tells you how many answers it should have, unless there's something called like a double root or a triple root. Sometimes one answer can work multiple times, so not always true, but generally this would have three answers, or whatever the biggest power is. That's called the degree of the polynomial. Another thing, this part is new. If you get an answer like 5 plus 2 squared is 7, if that is a solution for your polynomial, then its conjugate is also a solution. What I mean by that is just 5 minus 2 squared is 7. Remember back when we did quadratic formula?
Yeah.
Whenever we solved them, we would get things like plus or minus on the square roots. That happens on any polynomial, not just a quadratic equation. So if this is one of the answers, this is going to be one of the answers, or vice versa. Or if, I don't know, if this is an answer, guess what else? Yeah, so it's not complicated, it's just, they're called conjugates. Almost the same except for a plus and minus. Okay, this might throw you off. If this is an answer, guess what else is an answer? Negative square root of 6. Okay, this is kind of like 0 plus square root of 6. So 0 minus square root of 6 would also be an answer. But it just looks like square root of 6 and negative square root of 6. Also, that works with imaginary numbers. So sometimes we would get like something like this. Or just, it might just be 7i or whatever. But it's conjugate. If this is an answer, this is also an answer. Okay, same thing. Now, if I get a normal answer like 12 or 12 fifths or something like that, does that mean negative 12 fifths is an answer? No, that's not true. We're just saying with irrational answers, that's true, like square root answers, and imaginary answers, complex answers, that's true. Okay, we got a lot of these kinds of answers back when we were using quadratic formula. We still have to use quadratic formula some on this chapter, but it's always going to be the case. They called that some kind of theorem. A theorem is like a proven rule in math. They call it conjugate root theorems. Irrational root theorem, complex root theorem, yeah. You don't have to know that, but you do have to know that it's true. So, yeah, they go together. I mentioned this a couple weeks ago, but you probably forgot. Where did we start at? What are the solutions to this equation called?
Factors.
Zeros and roots. Good. I'm impressed. Good job. You guys comboed it. Zeros and roots. Okay, they're not called factors, but you can make a factor with them. So let's say, for example, I knew that 1 was a 0. I know. I'm not sure. I'm going to take too long to figure it out. If I knew that 1 was a 0 or a root of the function, that means it works in this equation. That means that x minus 1 is a factor. That's kind of what we talked about. Also, zeros and roots, when you graph it, they are the x-intercepts. It's where it hits the x-axis. So, like on the parabolas, if it hits here and here, or whatever, like if that's like 1 and negative 2 or something, those are the roots of the function, and they should also work when we plug it in and make it equal to 0. Because the function value is 0 when it crosses the x-axis. Like this is 1, 0. This is negative 2, 0. That means when the x value is negative 2, the function should equal 0. When the x value is 1, the function should equal 0. So when I plug in negative 2 and 1 or whatever, it should equal 0. So most of this is review, but which is good because you guys probably forgot most of this or never knew it in the first place. And in that case, we'll learn it again. Today's is a little bit trickier because unlike the last assignment we graded, we will get some square root answers. And the assignment we just graded, we had some just normal like 1, 2, 3 answers, but it shouldn't give us too much trouble. Okay, page 269. Are you guys there already? All right. Really, the A section should go pretty quickly. The B section is going to go very slowly, like the last assignment. For each statement, write 2 equivalent statements. Now, you might be asking, what the heck are they talking about? Well, you'll get it as soon as we do a couple examples here. So on number 1, it says that 2 is a 0 of P of X. What's another way of saying that? 2 is a root of P of X. And what else would we know? X minus 2 is a factor of P of X. That is what they wanted. Zero and root are synonyms. You guys know what a synonym is, right? It means the same thing. 0 and a root they mean the same thing. And then you just do x minus whatever the root is, and that's a factor. Okay. On number 3, it says negative square root of 7 is a root. So what else do we know?
Negative square root of 7
is a 0 of what? P of X. And if negative square root of 7 is a root, what is the factor? X plus square root of 7. You just do the opposite. So on number 2, it's a little bit different because they're starting with the factor. So if x minus 9 is a factor, then what's the root?
9.
Positive. 9 is a root of the function, and 9 is a 0 of the function.
So just
Yeah, that's all. All right. Number. Okay, these are the easiest ones. State the number of complex roots for each polynomial equation. So it's kind of like the first thing I asked at the beginning of class. How many roots would number 5 have? 5. Sorry, we're going too quick for that. Now, this should have an asterisk next to it. That would be counting like a double root as 2 roots and a triple root as 3 roots. So technically, it could just have 1 root that works 5 times. I guess that would be a quintuple root or something. But yeah, 5 is the easiest way to think about it. Okay, 7, 8, 9 I don't really like because it will just confuse you, but I'll just kind of walk you through it. Do you guys remember the rational root theorem? I kind of forgot to review that. Let me back up for a second. Does anybody remember the rational root theorem from a couple weeks ago? Okay, you might not remember the name of it, but you probably remember what it is I'm about to do. So the rational root theorem says if you have a polynomial with integer coefficients, these are integers, then possible rational roots of this polynomial are factors of the last coefficient over factors of the first coefficient. Is that ringing a bell now? Factors of 7 over factors of 3. Those are possible rational roots. Okay, we're gonna have to use that again today, a little bit, so keep that in your hat. But on number 7, all it's asking is what kind of coefficients are required to use the rational root theorem, and the answer is integer coefficients. So if you have like fractions and decimal coefficients, it would not work. So number 7 is integer. Okay, number 8, the irrational root theorem. That irrational root theorem, it just means like if 3 plus square root of 7 is a root, then 3 minus square root of 7 is a root. But that only works if the coefficients are rational, like fractions and decimals. So rational is the answer to number 8. And number 9 is complex root theorem, is like the imaginary version of this. If 3 plus 2i is a root, 3 minus 2i is a root, that's the imaginary or the complex root theorem. That only works when your coefficients are real. So the last one, number 9, is real. I'm not really too concerned about 7, 8, and 9. I do want you to know what an integer is. You should know what a rational number is. You guys probably haven't got that nailed down very well, but as far as these theorems go, I don't expect you to have that memorized, so don't worry about it. Okay, number 11. Given the following roots of a polynomial equation with rational coefficients, state all other known roots of the equation. So, on 11, they're saying we know these 3 things are answers. What other answers must exist? So, on 11, if 2 plus square root of 7 is an answer, 2 minus square root of 7 is an answer. So that's all you have to put.
Are eyes also?
Same thing with i's, yes. So number 12 actually has 2 answers. 2 more answers that you have to put down.
On 10 is there 2? Or 1?
No. 3 minus I is an answer, so its conjugate is also an answer.
3 plus I.
Okay, 13. Now this is where we actually have to earn our paycheck here. Did you? Are you rolling in the Benjamins?
You work 60 hours a week.
Did you work 60 hours last week? Dang.
How many hours do you work a week? Yeah.
I worked 0 hours. I got paid 0. No. I get paid salary, so I get paid anyway.
I can't ask you.
Well, did you do any work?
Well,
Rating or
a little
no
bit.
answer to school email? That could be reviewed.
Okay, so we're supposed to solve this equation. It says by factoring first. Any ideas? How can I solve this equation? It's not a quadratic equation,
Or synthetic division.
partially.
We could do that little thingy or take the -4 and
Okay, yes. The rational root theorem. We can take the factors of 4 over the factors of 1 and try to find an answer. This is from a couple weeks ago. Does everybody know where I got the 4 and 1 from?
Yeah.
Why didn't I put it as a -4?
Because it can't be.
Because the factors of 4 can be positive or negative, so it doesn't really matter. Anyway, what are the factors of 4?
Plus or minus 1, plus or minus 2, plus or minus
What are the factors of 1? 1.
1.
Okay, so the possible answers are 1 over 1, 2 over 1, 4 over 1. Or just 1, 2, and 4. But they could all be positive or negative, so there's only 3 possibilities. Or 6, I should say. That's good. How do I figure out which one actually works? Plug it in. Now you can plug it in normally, but remember we also had to kind of plug it in with synthetic division, called synthetic substitution in this case, to kind of divide the answer out. But before I do the synthetic thing, I'm just gonna plug it in. Plugging in 1 in my head is not that hard, because 1 cubed is 1. 1 squared is 1 times 4 is 4. So this would be 1 plus 4 minus 1 minus 4. So that equals 0. So 1 works. However, I am going to use synthetic to show that 1 works, because I kind of need to take the 1 out to find the last 2 answers. You guys remember synthetic, right?
Yeah.
Add down, multiply up. Multiplying by 1 doesn't really do anything, but add down, multiply. Okay, so that kind of reaffirms that 1 is an answer, because I got it to come out of 0. How many answers am I supposed to get on this normally? 3. So I'm missing 2. How do I get the last 2? Okay, you could still try plugging these in, but on today's lesson, probably the last 2 answers are going to be like imaginary or square root answers, so these probably won't work. So how do I find the last 2 answers?
You do the same thing.
Right here. X squared, remember this stands for x squared plus 5x plus 4. This contains my last 2 answers. And since it's a quadratic, actually this looks like it is gonna come out nicely. I lied. Okay, well, on a lot of the problems we're doing today, it's not gonna come out nicely. So, but on this one it is. So we can use quadratic formula or factoring. We're gonna have to use quadratic formula a lot today, but this one looks like it works without it. If you're not good at factoring, you can still use quadratic formula here. What multiplies into 4 that adds up to 5?
1 and
4
4.
and 1.
4 and 1. So what x values make these factors equal to 0?
Negative 1.
Okay, so my 3 answers are -4, -1, and +1. So it's kind of like,
Don't you have to write it like the factor version, like x?
no, that's what we did on the last assignment. Last assignment just said leave it factored. This assignment says solve it.
This is all.
That's all. That's why I circled it. Not forgiven.
Yeah.
No crying in my class.
You should get a sign that says that. No. Lily, who is she? Why is that her?
Talk about
Back row,
Yep. She got
Jess?
me.
Jess like X.
She got demoted. Okay. 15.
Do we have to put in zeros for missing
Huh?
Missing 3 squared.
Do we have to put in zeros for missing x's?
Yeah, for synthetic, yes. Here, let me put this right here. So, well, there's actually kind of a quick trick for 15. Getting very warm. So we could use the same trick as 13 and like factors of 36 over factors of 1, and we would get the right answers eventually. However, even though this is not a quadratic equation, it is in quadratic form. Okay, so normally a quadratic equation goes x squared plus some x's and then a constant, right? This is a quadratic equation. This is not a quadratic equation, but it's in quadratic form because this has no x's, this has x squared, and this has basically this x squared squared is equal to x to the 4th. So even though this is not This has no x's, this has an x, and then x squared is equal to x squared. This has no x's, x squared, and if we squared that, we get x to the fourth. We can factor this. What I'm trying to say is we can factor this like a normal quadratic. Okay, if it had an x cubed in it or an x in it, it wouldn't work. It has to be like in this exact form.
So we can do that for 16.
Yeah, 16 probably similar. Yeah, yes. 16 is a little trickier because there's like fractions, but yeah, it does work like this also. Okay, so what goes into x to the fourth?
X squared.
X squared times x squared. Okay, for the back, what goes into 36? That adds up to negative 13. 3 and 12, does that add up to negative 13? No. 4 and 9, can we make that add up to negative 13?
Yeah.
Yeah, if we do what?
Both
Make them both negative. Okay. No, you don't square root them.
I know, I'm a stupid question.
So, it's a little more complicated because this just doesn't just say x minus 4. Okay, if it was x minus 4, the answer would have just been 4. This says x squared minus 4. So how do I make x squared minus 4 equal 0? Well, yeah, you add the 4 over, you get x squared equals 4. If x squared equals 4, what does x equal? Plus or minus 2, right? You guys remember that trick?
Yeah.
Half of you got it wrong on that test. Whenever you use the square root, you have to use a plus or minus, because negative 2 squared also would work here. And same thing with the x squared minus 9. What x's would work here? If I add the 9 over, if x squared equals 9, then x could equal,
Plus or minus.
right, square root of 9 plus or minus 3. So how many answers did I get?
4.
How many answers was I supposed to get? 4. Yeah.
Do you mean 4 because positive and negative?
Yep, that's 2 answers. That's 2 answers. Okay, we could have used the trick for 13 on 15. It would have taken longer, quite a bit, because it started with x to the fourth, so we would have had to find 2 answers and taken them out to get it down to an x squared. So yeah, I recommend you, if you can, I recommend you factor number 16 instead of using the rational root thing.
What about 14, since it doesn't have,
14, on 14 you'll want to take an x out first. Notice all those terms have an x in it. That will get you down to an x. If there's an x on the outside, let's go back to 14 for a second. If you can take an x out of all those. Okay, if there's an x on the outside, what's one of the things that will work for x to make this equal to 0? 0. If there's an x on the outside, 0 could turn all this into a 0. So that's one of your, how many answers are we supposed to get? 4. Because it started out as x to the fourth. Now inside the parentheses, there's 3 more answers. How do we get the last 3? Well, you do what we did on number 13. Factors of 4 over factors of 1. And plug those in and see what works. So you can kind of, after we take the x out, you can say 0 is an answer and kind of ignore it. And then just solve this for the last 3 answers. Okay? Okay. Now, back to 17. X cubed minus 8. I didn't tell you guys this, but a cube minus a cube actually does factor. The reason I didn't tell you is because it's really hard to remember. how it factors. It's hard for me to teach. But we don't have to be able to factor it to solve this.
This is x plus 2.
Okay. Maybe some of you guys might be able to tell what x value would work here. That would make all this equal to 0. -2? Is that what you said?
No, positive.
+2. Because what's +2 cubed?
8.
8. So would +2 work? Yeah. So, but how many answers are we supposed to get though? 3. So 2 is just one of the answers. So we could have done the trick like, what are the factors of 8 over what are the factors of 1? And then be like 1, 2, 4, and 8. But we already know that 2 is going to work right here because 2 times 2 times 2 is 8. So we can kind of skip this part because we know 2 is one of the answers.
You're supposed to have 2 or 3.
We're supposed to have 3 answers, but 2 is one of them. And once you get down to the last 2 answers, that's the easier part because we can use quadratic formula.
1 to 8 or 3.
Okay, one of the answers is 2. 8 would not work. No, 8 cubed is not going to work. So what I'm going to do is kind of divide out the 2 answer that I know should work. Here's the thing though, this is missing an x squared and an x term. So when you do synthetic division, you have to put a 0 in. So this is like x cubed plus 0x squared plus 0x minus 8. We're missing 2 terms in the middle. So when you do synthetic, you need to put a couple zeros in there as a placeholder. Any questions on that? Okay, so then we do our magic trick here, add down. Now if we did it right, this should come out as 0 at the end because we want it all to equal 0. Times 2, add down, times 2, add, oops. Oh, I did something wrong.
You're supposed to bring the 1 down and then multiply across.
Oh, I multiplied too quick, that's right. Okay. Okay, there we go. Now we're back on track. Okay, the last 2 answers are in here.
It's 2.
Okay, this does not factor, and if it doesn't factor, what do we have to do?
Quadratic.
Quadratic formula. So basically my A, B, and C are 1, 2, and 4. So negative b plus or minus square root of b squared minus 4ac over 2a. Yeah, it's imaginary, so, because I got a negative under the square root.
Can't you simplify?
Yeah, square root of 12 is, this is where having a nice calculator can help you, is 2 square root of 3. So this is negative 2 plus or minus 2i square root of 3. Okay, remember, yeah, these are both divisible by 2. Remember I also had you separate the imaginaries normally? But yeah, they're both divisible by 2 anyway. So negative 2 divided by 2 is negative 1 plus or minus 2i divided by 2 is just I. So this is 2 answers, 2 imaginary, 2 complex answers. And then my third answer was that first, remember way back at the beginning, was that 2 worked. So comma